Let's explore linear transformations and one-to-one mappings in linear algebra. A linear transformation is a function that maps vectors from one space to another while preserving structure. Let's start by understanding what makes a transformation linear. A function t from vector space v to w is linear if it satisfies two key properties. First property, t preserves addition. The transformation of u plus v equals t of u plus t of versus. Second property, t preserves scalar multiplication. The transformation of c times u equals c times t of u. Here we see vectors u and v being transformed. Their sum u plus v transforms to exactly t of u plus t of versus. Every linear transformation can be represented as a matrix multiplication. We write t of x equals a times x, where a is the transformation matrix. For example, this transformation multiplies a 2D vector by this matrix with entries 2, 1, 0, and 3. Here's a grid representing our input space with standard basis vectors shown in yellow and blue. After the linear transformation, the grid is stretched and sheared, but remains a grid showing linearity. Now let's understand what it means for a transformation to be one-to-one. A transformation T is one-to-one if different inputs always produce different outputs. Mathematically, if t of u equals t of v, then u must equal versus no two distinct vectors mapped to the same output. In a one-to-one mapping, each input point maps to a unique output point. No two arrows share the same target. How do we test if a linear transformation is one-to-one? A linear transformation T is one-to-one if and only if its kernel contains only the zero vector. The kernel of T equals the set containing only the zero vector. The kernel is the set of all vectors x such that T of x equals the zero vector. Let's check an example. Is this transformation one-to-one? Consider our earlier transformation with matrix 2, 1, 0, 3. We solve the matrix equation a times x equals the zero vector. This gives us two equations, 2x plus y equals 0 and 3y equals 0. From the second equation, y equals 0. Substituting back, x also equals 0. Since only the zero vector is in the kernel, this transformation is one-to-one. Let's see an example of a transformation that is not one-to-one. Consider this transformation with matrix 1, 2, 2, 4. Notice how two different inputs map to the same output. This transformation is not one-to-one. Let's find the kernel by solving a times x equals 0. This gives x plus 2y equals 0 and 2x plus 4y equals 0. From the first equation, x equals negative 2y. The kernel contains infinitely many vectors of the form negative 2t tz, therefore not one-to-one. Let's summarize what we learned about linear transformations and one-to-one mappings. Linear transformations preserve vector addition and scalar multiplication operations. Every linear transformation can be represented by matrix multiplication. A transformation is one-to-one when different inputs always map to different outputs. We test for one-to-one by checking if the kernel contains only the zero vector.